Okay, so in the previous video I was explaining about my new transformers I was making using steel shims. These are my steel shims, and the way I've done it is space them out with plastic shims in between the metal ones so that they're staggered, so that it's basically plastic, metal, plastic, metal, plastic inside. And this is the end result after I wound one. Here's another one I've just made which I've not wound yet, so that's 3D printed, and the steel shims go inside there. So this is going to be replacing that one when I get this one wound, which I'm probably going to do today. It's tedious, but it's a lot easier with. It makes life a lot easier, but it's still tedious and boring. And yeah, the physical structure of this large transformer is there's such a lot more mass there. I didn't expect to get 100 millihenry, but I was hoping I would get something close to it, because you see the original choke that I wound was 80. I thought it was 87, but I was actually wrong, because I was connected in series. But the original thing that I did, which was on my other delay line, which is using a solid ferrite core thing, I got 76 millihenries on it. At least I thought I did. But I re-measured it, and it's not. It's like 8 millihenries, so I don't know what the hell happened there. Mind you, I was measuring between this end of this choke all the way through the circuit to all of these, so I was obviously adding up. The circuitry was adding up all of it together, and that's where I got the 76. But I'm not going to replicate that. I mean, I'm not going to start adding a load of chokes. It's just a lot of hassle. It's a lot of work, and it also relies on capacitors in the circuit, which I don't want to be using a lot of capacitors, because they actually create drag, and whereas the actual chokes themselves do create acceleration. So I'm not going to go back down that path, but the circuit is very similar to this one. This is basically half wave. This circuit was a half bridge circuit using a triac. So it actually is more symmetrical. This is asymmetrical, which means that the waveform clip, the triggering is half wave, so it's not balanced as well. And I had a lot of problems tuning this thing. This thing is very easy to tune. It's a lot more easy to tune, and it's more desirable than the original circuit. So what have we got so far? So at the moment, I've got my little 100 nanofarad polyester, which is stuck in the socket, which is the same as that one. It's got a socket in the bottom. This is 100, and I've got a socket in the bottom of here, and the legs are quite long, which is a good thing because I can pull it out. But this 100 nanofarad capacitor is really connected. Oh, where's my diagram gone? There's my diagram. Sorry about the red squiggly bit. This is where my two coils are actually terminated in the middle, and the two coils are on the same former. So I don't know if you can see this, but there's actually two separate coils wound on this toroidal array, so it's connected down there and down here for this side, and there's another coil wound all the way through between this side and that side. So we're actually connected, but they're working together, so they're not pushing against each other. The coils are synchronous with each other. So we get a balanced phase, and I am very interested in the results I'm getting with these new transformers. It's much more efficient than the previous design. It's doing pretty well, actually. My super capacitors are actually fully charged right now, so I'm not going to see a lot of current on the output, because the actual output voltage is being charged by the sun, because the sun's out today, and I haven't got this thing running right now. So but if we look at my supercapacitors, are already charged up to 14.6 volts. I could discharge them. I suppose I might try that. Let me just try and get them to trigger. I'm trying to get this thing to trigger. I'm tapping the sensitive area. When that blue LED comes on, it might trip. Come on, trip, 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 trip. I can't get it to trip. Come on. I've got all day. Blue LED when it comes on. There we go, I tripped it. Right, okay, it's tripped now. I want to discharge it a bit, you see, because it's starting to go down. Right, I'm going to wait until it goes flat and then I'm going to start my thing up so we can get an idea. So we can get an idea of what's going on. Yeah, I've been asleep and I'm kind of groggy. I'm still waking up. I've only got on the first cup of coffee. I'm on my first cup of coffee since I woke up, and I haven't even had the second one yet. So I'm waiting for that supercapacitor to discharge a bit, but it's not going to discharge. It's not going to discharge very much because the solar panel is supplementing the power. The solar panels are supplementing power to the battery right now, so it's not going to discharge very quickly, and I might not even get it fully discharged. It might only get down to about 6 volts, but still that's better than nothing. Up there, which you can't really see very well, I'm not going to reach and stick my arm right up there because it's hard work holding this phone up, right up near the ceiling, and yeah. So I'm going to wait until it clicks back on, and then I'm going to start this thing, and we'll just get an idea of output current once I do that, which is at 0 right now because it's not running. And also, I took my centre bearing back out again. I'll just explain why. This centre bearing that I put in the middle, inside the drum assembly, which was inside there, it was just causing so much extra drag. I just thought, sod it. So I came up with another idea, which was to put a collar between all the drums, the magnet drums. So what I did was I 3D printed a collar assembly. I'll just get my other 2 rotors to show you that, so you can get a rough idea. So, why is it stuck to everything? So what I did, these are 2 other drums. What I did was, there's a gap between each one, so let me just turn it around so you can see what I'm talking about. Right, there was a gap between each drum, and at high speed I was getting oscillation, so the drums would oscillate. I'm exaggerating it so you can see. There was oscillation on the drive shaft where they were sort of shifting around and oscillating and causing vibration. So I made a collar that goes all the way around, fills the gap, and has a ridge around the outside. That made them more solid so that the whole thing became one. Anyway, the relay just clicked, so I'm gonna start this thing up. We're only down to 7 volts. Shit. Oh well, that's better than nothing. Well, I'll just get this thing going. I need to put my choke on. There we go. Set the choke off. It's not really a choke, it just bypasses the trimmer pot, so it gives it an extra boost to get it started. So this is the waveform as it's starting to pick up speed. Right, let's go to the current output as it picks up speed. We're at 4,800 RPM right now. You can see that from over here. Anyway, yeah, I need to get this other one done as well. This is why I've got this. I've got to get this one wound today. it's made an improvement anyway, doing better than what we were. Input current at the moment at 430 milliamps, which is pretty low at input voltage of 19 volts. I'm only running it at 19 volts now, so we're actually using a volt less than previously. So instead of 20 volts, I'm running it at 19 volts at 420 milliamps, and then we're getting the same or more power out than we were when we were running it at 20 volts. Oh, the relay just clipped again. So the relay's just triggered again. It's going to discharge a bit more. Let's have a look. So the relay is it's discharging a bit more. So I'll let that go down a bit more. We'll see what we get to, because I wanted to get it down to 6 volts or 4 volts really, but the sun keeps supplementing the energy right now. But we're still pushing out 64 milliamps. Look, so we're pushing out 64 milliamps. Previously, when the relay was, because that's going directly into the battery right now, 65 milliamps, but normally that would have been at 30 milliamps when the relay tripped. So it's definitely pushing out more power now than it was before. Look at the waveform. Speed. Notice it's got a tilt. The waveform is actually tilting to the right. That's the phase shift. That is what I want. I want the phase shift I want it to tilt. I want the phase shift to be at a phase angle to overcome drag, and this is what we're getting now. It's starting to lean towards in the direction I want it to go. Oh, that is just tripped again, look. $450 milliamp. I'm not getting up, my back's killing me. I went and did my back in the other day. I don't know what I did to it, but yeah, it's charged up fast because the solar panel is pushing out 1.31 amps into the battery, so it's charged up a lot faster than, so we're not getting a chance to see things settle down, because at the moment the solar panel is supplementing power into the battery. So if you can see, we're actually pushing, there's actually 1.2 amps from the, so it's going up fast. There's 1.2 amps. Well, most of that is from the solar panel. So we're only pushing out 93 milliamps from the device, from the generator. So things are going to change rapidly, and this thing can't even keep up speed. It's trying to accelerate more and more to compensate and push out more current, as you can see from the twitching that's going on. Well, it was twitching, no it's not twitching. It was jumping up to 110, then down to 90, and then up to 105, and yeah. So anyway, just a little update. I don't want to film too long, because it's the videos get too long, don't they? So anyway, just wanted to give you an update on winding the coil, the new transformers, which are basically toroidal, using steel shims, and you can make your own toroids doing that way, but it's not, you could use steel washers, but the hole size is a lot smaller if you use washers, unless they're actually very big washers. But then the mass is a little bit too great with steel washers, really. These shims are very thin and they're ideal for laminations because they're about 0.5 millimeter thick, very thin. And I also put the generator on this towel because this old towel thing, because I got sick of things on the table rattling. I'll put things down on my table and they will start dancing around because when this thing gets up to 6,000 RPM, there's a bit of resonance and vibration. I've been trying to, as I say, I've been trying to get rid of the vibration by balancing things out better, but there's only so, I can only balance this thing so far, really. I need one of them bicycle things where they balance wheels, but I think that wouldn't work because they use a very large wheel area. But yeah, but anyway, I've got it balanced as best I can get it balanced, but it's just resonance, it's harmonics that are the problem. So yeah. Right, I'm going anyway now. I'm still waking up. Oh, the relay just tripped again. I don't know why. I must have upset it now. Anyway, we'll come back with more updates when I get this one wound and get this one in circuit. I left it overnight to dry. It's nice and dry now. The steel laminations are all inside there, as we can see from the magnet. Yeah. So, right. Thank you for watching.